Boys and girls, I'm on a roll today, I can tell you that right now. You shush! Today, or now, we're going to learn how to graph radical functions. Or at least I'm going to do my best attempt at graphing a radical function. So here is the base function y equals the square root of x. As you can see, we've got no negative x values because clearly that's undefined at that value. And the negative y values don't really work so well either, and we'll talk about that. So basically, how do I graph a radical function? Well, the first thing I've got going on is my 0, 0 point. That's going to go and continue on in the radical form fashion moving on forward. So the way that I like to graph these types of things are my x and y charts. I like to get friendly numbers so I can plug them in if I'm not graphing it on technology, by the way. And the friendly numbers will help me out. So if I plug in 0 to x, I get 0 for y. Now, I could clearly do 1, 2, 3, 4, and 5 and everything like that, but it's going to be really difficult for me to make points on this graph that work. So 0, 0, 1, 1. I'm going to skip 2 and 3, obvious reasons, because I get decimals. But I'm going to go to 4. Now, I realize that when x is 4, y is 2. Now, keep in mind the value of a radical sign. Especially when we solve quadratics, when we solve other things that we can take the square root of, you know that it's the positive and the negative version of that. Now, that's still mathematically true, but in terms of a radical, and I'm going to put emphasis on the word function, if I were to graph 4 and 2 for negative 2, that would defeat the purpose of it being a function. So by me saying specifically that it is a function, I cannot graph underneath in the negative portion of this graph. I have to stay with positive terms only because, again, there it would not be a function. So 9, 3, so on and so forth. Again, if you can get away with doing it on technology, perfect. Now, let's piece this together with transformations. Basically, when we do a transformation, we're just changing the origin or the origin point of this function, okay? So the one thing that I want to be really, really mindful of is what is the transformation doing in terms of the origin point? So take a look here. Now, I'm going to show you these as answers because it's just a little bit easier to work with. On the first graph, y equals the square root of x plus 3, all I did here was what? I moved the origin point or the original point of this function from 0, 0 to negative 3, 0, because that's a left 3 shift. Now, one thing that we also want to pair with this is the domain and range. If there is something that is moving horizontally, as transformations go, that means the domain also moved horizontally back. The domain of the normal function, y equals the square root of x, is 0 with a bracket to positive infinity. This, however, is negative 3 with a bracket to positive infinity, okay? Because I moved it 3 to the left. The range, there is no range value here or vertical shift that would have changed the range of this. So keep in mind, I didn't go up or down, so my range is still y is greater than or equal to 0. Now this one is a lot different. Keep in mind the origin point is now at 4, 4. Kind of like the vertex of this, opposite of that, exactly that, right? So I went 4 up and I went 4 to the right. So now my function looks like this, but because of these two transformations, the domain and range had to change as well. So the domain of the function now is, well, because I moved 4 to the right, 0 is no longer a valid factor of this, or a valid number that works for the domain. I went from bracket 4, infinity, and because I went up 4 on the y-axis, I'm also going to make my range go up 4 as well. Case in point, range is bracket 4, positive infinity. I'm going to put 2 more up there just so you can see it before my phone dies, because I knew it was going to do that. Make this a little hard. Ooh, that one sucks. Okay, let's go here. So left 5, up 4. That means left 5, up 4. Okay? There was no vertical or horizontal reflection, so it's going to look something like that. Again, if you wanted a graph to get pinpoint, make something here that's kind of friendly numbers. Like 5 would definitely work here. 6 would work here as well because I can get 1 when I take this down, or actually 6 won't work here. Negative 4 will work here, stuff like that. And again, the negative 4 has to work because I have a value here. Now it's up 4 because of the vertical shift. So the domain here would be, since it's left 5, bracket negative 5, positive infinity, and if it's a plus 4 up, the range would be bracket 4, positive infinity. That one's a mess. I don't want to do that one. Bye.